Talk Tuesday. Today, we're happy to have Dr. Mark SubbaRao, who leads NASA Scientific Visualization Studio. And we are excited to hear about his talk titled Designing Visualization for NASA's Earth Information Center. Thank you so much, Dr. SubbaRao. The floor is yours.
Yeah, thank you very much. A few months ago, I had the pleasure of attending the full cycle climate communication workshop at UMBC, and the presentation you're going to see is largely drawn from that. But what I'm hoping to do is at least tell you a little bit about the kind of work that my group does at NASA. So I lead the Scientific Visualization Studio, and our mission is to tell the story of NASA science. Generally, not entirely, we do all kinds of data visualization, but the majority of our work is focused towards communication to public audiences. And in particular, I want to tell you about a project called the Earth Information Center. So hold on a second, I will share my screen. And here we go. So on this title slide, the photo you see of the children is taken at NASA headquarters in downtown Washington, D.C. You see them interacting with a giant display we have, which we call the Hyperwall, which is part of this physical display of a variety of Earth science information. Now, the first question many people will ask when we talk about NASA building an exhibit about Earth science is, why doesn't NASA study space? Why are you talking to us about the Earth? And I think the best answer to why is perspective. And there's no better example of perspective than this photo, the famous Earthrise photo taken on Christmas Eve, 1968 by Bill Anders. As a quick aside, that Bill Anders, who passed away last year, there was some debate over who actually took that photo. And Ernie Wright, a member of our group, the Scientific Visualization Studio, by studying the images taken by the astronauts, was able to reconstruct the orbit and figure out that it had to be Bill Anders that took that photo, settling a long-term controversy. But the image itself is perhaps the most famous image ever made, arguably the most important photograph ever taken. It is credited with launching the environmental movement, the beginnings of Earth Day. But it's not just perspective, the human perspective, but it's the perspective of our satellites that really transforms our view of the Earth. So here you see a current view of NASA's Earth observing fleet. And it's the information coming back from this fleet of satellites, combined with other measurements on the ground and simulations and models, that we present to the public at the Earth Information Center. And the idea for this building a physical center came from this report. So this was a World Economic Forum white paper entitled Space for Net Zero. And as part of that, they had three recommendations for how the space industry, or how space in general, could help us as a planet achieve net zero emissions. And interestingly, one of those three was something they call an Earth Operations Center. And they talked about it, they centered data visualization in that. And for someone like me who works in data visualization, this is very exciting to see the importance they were placing on it. So you see the quote I have in the upper left. They described it as a data visualization environment in support of decision-making by world leaders. And they talked about the importance not just of it being, of it existing, but that it was a physical space, not just a virtual space, right? So they wrote here, an Earth Operations Center would be a physical and functional expression of the willingness to make that commitment. And in the text, if you read it, they make a lot of references to the Apollo era, thinking again back to that Earthrise photo, and how the mission control was key to the Apollo missions. And in the same way, we needed an Earth Operations Center to be key towards battling our key environmental challenges. If you look at one of the authors on that was Alex McDonald, who was at the time NASA's chief economist, and he brought that back to the new NASA administrator, who was Bill Nelson at that time, and immediately we started making plans for building such a facility. Right, you see that quote I circled there. Just the importance they were placing on the center was pretty remarkable. So this center is built on top of the work of the Scientific Visualization Studio that has been around for more than 30 years. It's perhaps the largest group of its kind in the world, I believe. About 20 people dedicated towards creating visualizations about all of NASA science, but with a particular focus on Earth science. Here you see a recent redo of one of the more famous SVS visualizations, something we nicknamed Perpetual Ocean. It's a visualization of global ocean currents. This is a short clip. We have a full tour of the various current systems on the western boundary currents that we just released recently on our website. We are co-located with one of NASA's 2 supercomputers. The Discover supercomputer is part of the NCCS here, and they visualize, they simulate work like this. Is the Goddard Earth Observing System model, and here you're seeing a very high resolution model, 3-dimensional model of carbon dioxide. And so this is kind of, I think, really pushing the boundaries. You see both the cutting edge of the models we're able to run here, but also the visualization that we're able to do. This is getting down to 1.5 kilometer resolution. At that resolution, we can see plumes coming from individual power plants. Pulling back and looking at a global view, this is now about 40 days in the winter, so it's but in the tropics, we can see the breathing of the Earth, and that's the biosphere. You see it breathing in CO2 during the day and breathing it out at night. And overall, it's breathing in more than it's breathing out. And that absorption, that's year-over-year absorption of CO2 by the biosphere is helping to ameliorate the effects of human emissions. But yeah, it's fascinating to watch the sort of daily pulse and the cycles of our planet. Here's another example of the kind of visualization we do. This is of an event. So this is showing you the Dixie Fire in California. This was the largest wildfire in California history. And NASA observations are able to track basically at 12-hour intervals, twice a day, the progression of fire. So we're seeing here both where the fire is active and the boundary where it is currently burning. You're seeing that progression over time. What we'll do at the end is we'll lay in all of these contours showing you where the fire progressed the fastest. And in particular, what you'll see is in some cases, the fire can grow quite a lot between some of these individual contours, indicating the need for even better coverage than we have now. We were able to do something recently for the LA wildfires, and we're just about to release that. So stay tuned, but you'll see a video soon for the LA wildfire. Here's another recent release. It shows a different kind of visualization that we do. This one is, it's showing the results from the first year of operation of the SWAT satellite. So it's kind of a tour of some of the interesting results. And what we really wanted to show here through the visualization is how much better SWOT is able to resolve features than previous measurements. So we're actually getting down there to seeing features as small as a kilometer across. And that overall resolution is 100 times better than we had before. And that allows us to see these little features, these circular eddies that show upwelling of nutrients are very key, but just washed out with lower resolution measurements. Interestingly, some of these features, even though our satellites weren't able to see them, but some of these circular features, and you have some great examples of them here, were actually seen by the Apollo astronauts from space. And one thing that I find quite remarkable is we can even resolve features from reflections off of ships. So I'm hoping to give you a sense with these of some of the different kinds of measurements we do. So we have visualizations of computer models. We have visualizations of observations. We also have visualizations showing you how that data is taken. This is a visualization of data from the GPM mission, the Global Precipitation Mission. And it's able to take a sort of three-dimensional CAT scan of hurricanes. The interesting thing about this one, and this is, I think, is that we kind of have to be lucky and pass the hurricane at the right time with our satellite swap. In this case, over the course, and I believe this is Hurricane Milton, from last year, we were able to get actually 4 passes over it. I may not show them all, but you'll see some go over the center, some are more on the outer edges. And this was an interesting one as well, because we had actually organized a conference at the IEEE visualization workshop, the world's biggest data visualization workshop around climate change communication. And that workshop was first the hotel where it was going to be was damaged by Hurricane Helene. Then it got moved to another hotel from St. Petersburg Beach to downtown Tampa. And then Milton was coming and we had to cancel the conference altogether, at least the in-person part of the conference. So when we had our workshop about climate communication, it was very easy to make the point to why it was important. And we also will do visualizations for key natural events. So in this case, we're looking at a visualization that's going to show Arctic sea ice maximum. So it is showing you the progression, the growth of sea ice from Arctic minimum all the way to Arctic maximum. And then, so we put that out in March, and then in September, we'll put out a visualization doing the reverse from Arctic maximum to Arctic minimum. And likewise, we do the same thing with the Antarctic. So these are 2 products that we put out every year. As well as we are constantly updating visualization. In this case, it's side by side, so we sort of see the progression of the seasons in opposition. And this is being updated every day, this video, and it's downloadable on our site. And this kind of pipelining of visualizations so that we can constantly create them is something that was new to our group. It's something we did specifically for the Earth information centers. So before then, we tended to make things for events, for press releases, but now that we have this display of near real-time information, we're making more and more visualizations for these particular events. Now, recently, as we reached a point where that combined sea ice reached an all-time low, and here's a graph visualization showing that. So what we're going to do is we're going to show you both the Arctic and the Antarctic sea ice in a graph form, as well as their combined total. And just recently, earlier this year, we hit our all-time low, as you can see, as we warp this graph from that contextual grid seasonal view to this time series view. So that's an example of physical events that we create data for, but we also sometimes sort of create our own events and or have seasonal events. And one big seasonal event for us is the annual temperature announcement. So NASA, through the Goddard Institute of Space Studies, which is located in New York, is one of half a dozen keepers of the global temperature record. And every mid-January, we have a press release where we announce last year's temperature, and we do this in coordination with NOAA. So we do the measurements independently using the same data, but different techniques, and then we both announce our results in the same press conference. Last year, of course, was the warmest year on record, as was the year before. That video didn't really play, but there was a map. Let me go back and see why it did not play. All right. Anyway, I'll continue on. That global measurement comes from these observations. So these are measurements coming from weather stations on land and the combination of sensors on sea. You have buoys, some are free floating, some are moored. You have measurements on ships, which we're seeing in yellow, and tidal gauges as well, and a number of other different sensors. So this is trying to show you the global coverage that we had, and this is specifically for the year 2023. Now, we try to present data in a number of different ways. This is another representation. You had the map, which didn't play very well for whatever reason, but this is a visualization called the climate spiral, and it's trying to find a new way to present that data. So this is based off of a visualization that Ed Hawkins had done many years earlier, but with sort of an added twist to it. And this is a kind of visualization that will play very well on social media. And when I say twist, I mean quite literally a twist. So we go from that two-dimensional spiral graph view to a three-dimensional view, which now is acting as a graph. Now, if you were a data visualization professional, you probably have been beat into you a couple of things. One is that 3D is bad for graphs. Another is that you should avoid using animation. I actually disagree very strongly with both those things. And I see this is but a lot of this depends on what your goal of your visualization is. In our case, our goal is not to create things that people can read numbers off of effectively. Our goal is to get people to pay attention or to and to be interested. And in our environment, in our media environment, which is incredibly complicated, and honestly, the way most people are consuming our content now, which is on social media, as they're flipping through their phone, we want to make a visualization that will make them stop and watch. So here's another example like that. This is a similar visualization. It's sort of a morphing graph, but was also produced for the temperature release announcement. It's showing how these two record years really stood out, along with 2016, the previous record holder, but especially 2023 and 2024. how much they stood out among previous years, being significantly warmer than any previous year. And that was throughout the course of the year. So I think when you're watching these visualizations, there are a couple of themes that at least I tend to think about in the way like in the work that we create. One is that so much of what we want to talk about is abstract data. Um, and that abstraction is a challenge. Visualization is one way to deal with the abstraction, but if you do that visualization in a way that's not just visual, but also almost tangible, um, you're engaging even more senses. And what do I mean by that? Of course, we're still presenting flat data on the screen, but we're rendering it in a way that makes it look like it's something you could reach out and touch. At least you can imagine embodying that interaction with it as a physical object. And so the sense of some of these visualizations is making something that's physical and touchable. Here's one of my favorite examples for that. This is showing tree height data coming from the JEDI instruments. This is an instrument aboard the International Space Station, and through LiDAR, it's building up through each pass of the ISS. It's building up this global map of tree height. And the visualization is very much chosen to have this sort of color sense that makes it feel like this mossy ball. You can almost imagine touching it. And that, I think that tangibility really helps you remember what you're seeing. And it can also, in this case, we're looking at a map of extreme weather events. And so when I show you something that's wet, I want it to have a highlight, look like it's wet. When I show you the red events, which are dry events, I want them to look like clay, right? They look, and they don't look shiny. They look like they would be rough to the touch. Another thing that we think about is, well, there's this term that's really popular now called data storytelling. And honestly, I think it's vastly overused. And I can't claim that most of what we do is data storytelling, but it has elements of storytelling. And so I think of it more as sort of data storification. How can we take these elements of storytelling and imbue them in our visualization, right? So if I think about something like the climate spiral, I'm building up suspense with the spiral. And then there's a twist. Here's another example of one of these graphs. So this is for global sea level change. And you see here this seasonal lapping of waves is the data is really trying to represent the waves by the way it's drawn and the way it comes on. And then we have the shift showing the rise, right? So with the color, with the way it's drawn, I'm trying to make it feel like it's water. I'm building it up slowly over time to give you suspense. And then I have this kind of surprise ending and a resolution. We can also take a more literal data storytelling approach. So this is something we designed specifically for the Earth Information Center that we call sea level through a portal. So this is looking at exactly the same data set, global sea level, and you're pretending though that you're looking through a porthole in a ship, and you're watching as NASA's 33-year record of global sea level rise occurs. Interestingly, we made this specifically for the physical display at NASA headquarters, which is a circular display. And we scaled it so that it's true to human scale. 1 centimeter is 1 centimeter. I would have thought that since it was made specifically for this site, it would really only be interest in this site. But this visualization went viral on the internet, even shrunk down on someone's tiny phone. Here's another example of these kinds of graphs, how do I make this graphical data more interesting? So this is a different way of representing the Keeling curve. So this is our record from Mauna Loa of carbon dioxide, and NOAA's record. And you see the buildup year over year. You see the little wave, which is the seasonal variation. When again I do this twist effect, I'll be able to pull that into the time series, a more conventional Keeling curve. And then I can use the zoom to bring in the paleo data from Antarctic ice cores and just show you by gradually changing that scale just how extreme the recent rise in carbon dioxide is on a geological perspective. And we'll eventually take this all the way out to 800,000 years. These kinds of morphs I'm really fond of. Here's another example. I showed you the still from this before, but this is from a semi-recent result that was showing how there seems to be an increase in both the number and the intensity of extreme, both wet and dry events, so that both wet and dry events are increasing both in frequency and intensity. So the volume represents the intensity, and then you sort of see the number. So we switch from this graph that kind of shows you the number of things to a map over time, showing you where they occurred. And here's another example of data storytelling, but more traditional data storytelling. So here you'll see us taking some of these visual components we produce and putting them together in more of a story. And this is one of the more complex visualizations that we created specifically for the Earth Information Center. And it's showing you a year, the story of a year of carbon dioxide on our planet. This model of CO2 is broken down by 4 components. So we know what's being emitted by fossil fuels. We know what's coming from biomass burning, wildfires. And then we see the exchange of CO2 that's happening from the ecosystem on land and in the ocean. So some of these components are positive, some are negative. There's a little graph in the lower right corner, which is giving you an accounting of these various components. You see now we're halfway through the year and we're net negative because with most of the land being in the northern hemisphere, we're having, as we get through northern hemisphere summer, we've had more absorption than we've emitted. And actually, we'll stay for the year. We'll actually stay net negative in CO2 till the very end of the year. But as winter comes in the northern hemisphere, that'll start to turn around, and you'll see by the end of it, we'll be 2 parts per million higher than we started the year. But the other part that this shows is that the work that the land and the ocean are doing for us. So you'll see about half of all the emitted carbon dioxide has been absorbed by our planet. And that means it's not going into the atmosphere and warming the planet. So that is showing you some of the data visualization work, and that is what went into this physical exhibit, this physical data visualization exhibit that we initially opened at NASA headquarters in 2023. It consists of 4 components. I kind of think of them as like representing different kind of components. So there's an immersive exhibit, which is space for Earth. It's almost like the heart. It's telling you why we want to go, why we should care about our planet. We have the Earth Pulse, which is a data sculpture that tells you about sort of NASA's eyes. It's showing you the flow of information to and from satellites through this like artistic sculpture. And then there's the Hyperwall, which is a large LED display you see there with Bill Nye, where we deliver a lot of the data visualizations I was just showing you. And we also have a giant NASA worm, which everyone loves to come and take photographs in front of. including these astronauts. But yeah, just quickly, here are some of those components. So this is the NASA Pulse exhibit. It's connected to the Near Space Network, which um, which handles communications to all of the satellites in near Earth orbit. And so you saw their Landsat 7. So it announces what satellite it's talking about, and then it's showing you real time, within 30 minutes, the amount of data that's going down through the amount of light going down, and then also information coming back up to the satellite in terms of instructions. We also have an immersive room experience, which is narrated by an astronaut. It gives you sort of overview effect, and also has some interaction where you get to play. So here we're looking at night lights, and of course the hyperwall, which I mentioned before, which my group is responsible for producing content for. Here's some of the visualizations you saw. I just showed you this visualization, but here you see it laid out in a slightly different format for the hyperwall. It's a beautiful display. So we have this 8K display, main display, and we have two circular 4K displays on either side that we're able to create these dashboard views and break down a lot of different information. And we'll cycle through content on this display related to various themes. For example, we have themes around biodiversity, around agriculture, around wildfires, and around natural disasters. Because of the location at NASA headquarters, it's a great place to bring people through who are visiting DC. This is a group of Latin American leaders, mayors of Latin American cities. Here I'm going to show you in time lapse the loop of content that plays on this. And we break that content in a few different formats. There are narrated stories. We just flashed by one about wildfires, which tells you about how NASA data is being used by end users, whether they're like resource managers, city planners. We have dashboard views, which support that with lots of real-time information about various views of our planet. And we have these large visualizations that cover the whole screen that we call beauty pieces, which are really just kind of to bask in sort of more of the beauty of data visualization. As you can see, it is a lot of information, especially when it's played back at super fast speed. Yeah, and so a little bit more of what that looks like at more normal speed. So we've been able to take through a number of interesting people. We see, members of Congress in the lower right. Our Earth Science Division Director, Karen St. Germain, is talking to the Prime Minister of Mongolia. In the upper right was a really interesting day where we had a group of indigenous leaders from the Amazon came through. And it was really interesting to see them interact with the information wall and also tell their stories about, how they're using NASA data and, how, the changes that they're seeing in their environment. It was pretty powerful. Now we're expanding this concept as well. So last year, we opened our second Earth Information exhibit, and this is at the Smithsonian's National Museum of Natural History. This is a large exhibit It includes a couple of different kinds of interactive things. So this is a camera-based interactive showing images changing over time. We have an even larger hyperwall exhibit. So here you see our former administrator Bill Nelson with Kirk Johnson, who's the president of the Natural History Museum. And our third large installation is going to be at Kennedy Space Center, where that is under construction now. We hope to be open in about a month or so in this building here. New stop on the tour. This is out at Launch Complex 39 at the Gantry at LC 39, it's called. And this is the launch complex that famously is where the space shuttle and even Apollo launched from. One interesting side story is that there are challenges to building near a launch site. So this was our hyperwall we're building there. And after installation, we found that the LED panels were being damaged by the vibrations from the rocket launches. So we've actually had to redesign those panels a couple of different times so that they would not be so susceptible to the vibrations. One of the things that we try to do as well, and you'll see in some of the interactive components, is try to take some of this global scale information that I've been showing you. I think it's very important, and make it personal. This is an example of that. So this is an interactive. You can try it on your phone. It's much better on your desktop. There's a QR code there. It's based on a figure that was in the last IPCC report that was quite well known. But here you can take this, and the idea is it shows you the warming stripes, but in the context of different generations. But rather than making them generic people of various ages, you can now put in your family and make one for your family. So this is a set of climate stripes for my family. And here you can also lay it out like this, and this is kind of the t-shirt version of that. So you can pick not only your age, but also icons that represent you and your interest at those various times. Another thing we put this exhibit in at the Museum of Natural History. It's something called Hometown Dashboard, where you can zoom in and see climate projections for your hometown. And in addition to these big exhibits, we also take this on the road. So we take it to a number of conferences. Portable hyperwall, here you see it at the UN Climate Conference. And I think I'll just close there. I think one thing that, as we present all this information, but particularly information that has to do with natural disasters and hurricanes and wildfires, and especially information that has to deal with the warming of our planet, there's always a fear that this might create anxiety or climate anxiety. But I think part of the big story that we hope to convey by showing all of this information together is just how much we understand as scientists. And our former, Kay Calvin, who's former NASA chief scientist, she would like to say that science is hope. And our goal, I think, is by presenting that all together, is to really show you how much we do understand about our planet. And interestingly, I have a link to a paper there, but there's actually research showing that the more environmental knowledge that people have, the less anxiety they feel, less climate anxiety they feel. So that there actually is power in knowledge. So let me just finish. Invite you. Everything I've shown is freely available for all of you to use. We put it out in layers so you can remix and reuse it in your own context. So please check out our website for that. And also, I encourage you to come downtown, visit the Earth Information Center, either at the Smithsonian or at NASA headquarters. The NASA headquarters is open Monday to Friday, 8:30 to 5:30. And I want to thank you very much for your attention.
Thank you, Dr. SubbaRao. The floor is open for questions.
Thank you very much. It was very interesting. As before at the workshop, I was always curious about your process, how you select the data sets. Do you start from the data set? Do you start from a problem? And then what the process of the design is?
Yeah. Of course, the answer is always it varies from project to project, but in many cases we do start with, well, we start with two things. We tend to be data first, so we want to get our hands on the data as soon as possible and explore. So of course, whenever we're starting a new project, we'll meet with the communicators and also the scientists so that we understand, all right, what are we trying to convey with this visualization, and what are the key things to know about the product. But I think the real magic happens early on when we say, like, let's get our hands on the data as soon as possible and just start exploring and seeing what it looks like. Sometimes that will go in the direction you imagine when you're doing that initial planning, but in many cases you might explore through the process of just looking at the data and trying to understand it yourself, come up with a new way of looking at it. One example I might give is with the PACE mission. So around last year at this time, we were the PACE mission, which is this ocean observing mission. It's hyperspectral data. It also has polarization data. It also views at multiple angles. It's incredibly complex data. So in many, our first round of visualizations was actually just creating visualizations so we could understand the data first. And out of that, we chose things and a subset of those to share with the public.
Thank you. That's really interesting. Do you do any evaluation, any testing with the visualizations?
You know, we don't do as much as I'd like, but we did recently do, and it's hard because we kind of send stuff out in the world. But with the exhibit at the Natural History Museum, we actually had a captive audience. So we're able to hire an external evaluation firm. And they came in and both observed people, you know, measured how long they sat, and then interviewed them as well. And the results were actually really good. We're very pleased. Now, that was very much top level evaluation. So we had certain goals for the exhibit, and people certainly showed interest. They had good dwell times, and there's always the question of, like, all right, if you ask them in detail about individuals' visualizations, would they understand them all? Probably not. And we didn't actually do that. But at least in terms of our top level goals for the exhibit, it was quite successful.
I mean, it all looks fantastic, so I can't imagine it wouldn't be, but thank you.
You're welcome.
Yes, while people are thinking of other questions, I was trying to tamp down the number of questions I have. So maybe I'll start with one. So for several of these, you have to crunch a lot of data, obviously.
Yep.
And you're using high performance computing, I imagine, for many of these
Yep.
data processes to process into visualization. So for the actual exhibits, some of them which are real time, do you have real time high performance computing processing in the back end, or do you extract the visualization?
Yeah. So we extract the visualization. So, and that can be in different ways. So on that big display, you'll see a combination of things. It's playing back videos, and there are also web components. So the web components are generally something that's accessing a pretty small or optimized data set. It's actually a challenge that we're dealing with now at the museum, where the web connection's not great. So sometimes we've been having things come up a little slower than we want. In the other cases, it kind of depends. If it's some of the biggest visualizations, like say that carbon dioxide visualization I was showing, which is one of the largest, that's something we're not really able to do operationally yet. So we spent many months of like pre-processing that data and had visualization, and our rendering of it was, took more than a week on our farm of 100 and some nodes. But there are other other visualizations that are using some of this model data that's a little bit smaller and the visualization is a little simpler that we are running every night. So we'll run that on the supercomputer, render out the frames, build the movie, and then overnight, in the middle of the night, we copy it over. So we're playing a movie that's current to the present day. So yeah, it's a combination of like pre-processing stuff on the computer, or some things that are just infrequently done.
Mm-hmm. Interesting. If I can ask one more question, you mentioned that some of these at the website, the SVS website, we could interface to some of these types of visualization. So I'm wondering if the interactive visualization that you showed, is there a way to interface to that? Because as you were presenting, I was messaging my student that it reminded me of his work. Are there ways to interface to that interactive visualization, the pulsing visualization that you showed?
Yeah. So that one is that one's updated every day on the website.
Okay.
And yep. So you could pull a version every single day if you wanted.
And is it okay to reach out to you if you're trying to connect?
Yeah, of course. And so if you go to the website, my email is on the bottom of every single page as the NASA official, and yeah, so feel free to email through that. It's probably better to email directly. If you email through the forum, I'll probably have to fish it out of quarantine, but I'll find it eventually. But,
that's great. Yeah, the good thing is we have your direct email now, so we can.
That's right. Yeah.
There's a question in the chat. Does NASA have plans for future products and visualizations coming soon?
Yeah. Well, we're always working on things. Let's see what are the big projects we're working on. Well, there's one in heliophysics that was pretty exciting this morning, which is having to do with how the Earth's ionosphere and thermosphere responded to this big solar storm that happened at Mother's Day last year. So I just saw a preview of that this morning. I was pretty excited about. I think, yeah, we've got a number of things coming out. But I can't think of anything else that's really exciting. We're doing some work with agriculture as well. And a GitHub repo. Not really. It's something I'd like to start. So there is a NASA does have a NASA GitHub site, and I made an SVS repository on there. But I got a little bit scared. This was when I was first starting, about like the rules about like when I can make something, the process to open source software. But there's been a big movement with NASA with something called TOPS, the Transformed Open Science. So I'd like to do more. I have at least test examples where, along with the visualization, I've delivered an IPython notebook file that you can use to generate the visualization yourself. And so we've done that, but we don't do it as a matter of course, but it's definitely something I'd like to do more of. And one of the interesting things, because so much of the work we do, and generally our workflow is, half of it's like using things like Python to read the scientific data. The other half is we port that into commercial visual effects software. And that's harder to share, because if you don't have this software, you wouldn't be able to do anything with the files. But now in the computer graphics industry, there's a new format, an open source format called Unified Scene Descriptor, USD, that seems to be becoming more and more popular. And so that might be a way to distribute the sort of models behind the visualizations in a way that could be brought into a lot of different code.
I have a question regarding the data sets. So if you are all the data sets owned by NASA, generated by the satellite data, or have you found yourselves having to integrate with external data sets, and how do you get access to those in order to, generate these visualizations in a timely
Yeah,
manner?
so in many cases we do integrate with external data sets, or it's a data set through a NASA's partner, right? For example, like I think at the beginning I showed the plot of the sea ice, and so that's produced with NASA data, but that sea ice index is produced by the National Sea and Ice Data Center, and well, unfortunately, I think it recently announced they're not going to be able to continue making that product, or hopefully someone's able to take that over. So it varies. We try to always link to what that data set is. In some cases, we're working with stuff early on because we want to have a visualization. So maybe even if the goal is always to have it publicly available, it's not quite yet. And then when it's working with a partner, in some cases it's just easy to get it from their site. In other cases, they might make it available for us.
Okay.
Can I ask one more question? Sorry.
Of course.
So I think a lot of the visualizations you shared had like a global viewpoint or large scale viewpoint. Do you have to make that as a conscious choice, or do you also do local visualizations for parts of the world or parts of the country?
We do, and we're often asked for the local things, especially when someone from Congress is coming through. They want to see their state, right? But in many ways, the nature of NASA visualizations is that they're often, it's the satellite data, is that it's a global thing, and also the power is in the global nature of that. And sometimes the message as well, right? So when we look at, say, smoke from wildfires, you can zoom in, but the fascinating thing is to see that smoke is traveling around the globe, right? Or that dust from the Sahara is coming over to the US. So, it's a complicated answer, but I think it is, one, it's inherent in the data, and two, it's often inherent in a lot of the messages that we really want to show the interconnectedness of the planet.
Thank you.
Oh, one other question in the chat. Can citizen science be helpful and be as part of the project?
Oh yeah, absolutely. Absolutely. For a lot of this, a lot of data collection, and I would point you to the Globe Project, which is a whole collection of citizen science projects that NASA is involved in. But NASA has a huge effort in citizen science across the sciences. A lot of projects in astronomy, a ton during the eclipse, but also a number of earth science projects as well.
Thank you. We may have room for one more question. Anyone? Thank you, Rhoda. Which visualization has changed leaders the most?
Oh, wow. I don't know if I can answer that. I wish I could answer that, but I just, it's hard to know, like, and to know, especially if you're talking about if you can change a leader, it's really a challenge, right? So I don't know. I hesitate to say. I know that our climate visualizations, our temperature visualizations have been very impactful, because that's very policy relevant. We've done some things, yeah, and I hate to say the most because there's so many of them, but I think I see certain things resonating more with policymakers. Some of the things, for example, we've done with agriculture projections, but it's a tough question. I wish I knew the answer, but you often don't know. There was a great article with Boris Johnson, which was something like the 5 or 7 figures that changed Boris Johnson's mind about climate change. They weren't any of ours, but it's an interesting article if you want to see like communicating towards policymakers.
Thank you. Okay, I think we can close out. Thank you so much, Dr. Max SubbaRao. It's been very, very insightful. Some folks are asking for your contact information in the chat, your email, and that will be helpful. And we'll have the presentation app on our iHARP channel as well, so people can go back and revisit and explore some of the visualizations that you've shared today. Thank you so much, everyone, for joining us. It's been wonderful. And yeah, his information is in the chat.
Yeah, thank you very much. It was a pleasure talking to you.
Thank you.
Thank you.
Thank you.
Good night.